The way a vertebrate opens and closes its mouth, how it bites, chews, or captures prey, depends entirely on how its jaw are suspended from the skull. This connection between the jaw and the skull is known as jaw suspension or jaw suspensorium. In vertebrate evolution, jaw suspension plays a vital role in feeding strategies, skull flexibility, and the transformation of jaw elements into inner ear bones. Studying jaw suspension helps us trace the evolutionary lineage from early jawed fishes to modern tetrapods and mammals. In this video, we will explore the types of jaw suspension in vertebrates, classified based on how the upper and lower jaws are connected to the chondrocranium. It is the cartilaginous part of the skull in the early development. Before understanding the types of jaw suspension, let's quickly go over the main anatomical parts involved in the jaw suspension. Chondrocranium, the cartilaginous part of the skull in the early vertebrates. It provides the base for the jaw attachment. Quadrate, the cartilaginous or the bony structure forming the upper jaw in primitive vertebrate. Meckel's cartilage, a cartilaginous bar that forms the core of the lower jaw in the early development. Hyomandibular, it is a part of hyoid arch. In fishes, it helps suspend the jaw. In tetrapods and mammals, it evolves into the ear bone, stapes or columella. Quadrate bone, originally part of the upper jaw in non-mammals, it articulates with the lower jaw. In mammals, it becomes the incus of the middle ear. Articulate bone, it is the part of the lower jaw that connects with the quadrate. In mammals, it evolves into the malleus. Dentary, the main bone of the lower jaw in mammals. It replaces Meckel's cartilage as the lower jaw becomes fully ossified. Ligaments, basal ligament, otic ligament, ethmoplatean ligament, spiracular ligaments. These are fibrous connective structures that attach part of the jaw to the skull in various types of suspension. Last is columella or stapes. It is a small bone of the middle ear derived from hyomandibular. It involved in sound transmission in tetrapods. These components are rearranged in different ways across vertebrates group, forming the basis of different jaw suspension mechanisms through evolution. Now let's talk about the types of jaw suspension in vertebrates. First one is Autodiastylic Jaw Suspension. The jaws are attached to the chondrocranium by anterior and posterior ligaments. The hyoid arch does not support the jaws and remains completely free. A complete gill cleft is present in front of the hyoid arch, usually forming a spiracle. A key structure include the basal process, otic process, Meckel's cartilage, and plateau quadrate. This is considered the most primitive type of jaw suspension, and it does not involve the hyoid arch at all. And these are found in some primitive bony fishes. Next is Amphistylic Jaw Suspension. Upper jaw is attached to the chondrocranium by both a basal and an otic process through ligaments. Hyomandibular of the hyoid arch also helps support the jaws. Therefore, both the chondrocranium and the hyoid arch contribute to jaw suspension, a double suspension. Amphistylic suspension represent an intermediate evolutionary condition which is more flexible than autodiastylic but less so than hyostylic. And these are found in Crossopterygii, which is also known as lobed finned fishes. Next one is Hyostylic Jaw Suspension. The upper jaw is not directly attached to the cranium. Instead, it is suspended by hyomandibular, which is attached to the otic region of the skull. The ethmoplatean and spiracular ligaments connect the jaw indirectly to the cranium. The lower jaw is also supported from the posterior side by hyomandibular. This type allows greater mobility of the jaw, ideal for suction feeding and jaw protrusion, and these are found in elasmobranchs, which are sharks and rays, and many bony fishes. Next is Autostylic Jaw Suspension. The upper jaw is completely fused with the cranium. The lower jaw is suspended from quadrate bones of the upper jaw. The hyomandibular is no longer involved in the jaw suspension. It gets modified into columella or stapes of the middle ear. This type represents a major evolutionary shift from jaw support to sound transmission, and these are found in lungfishes and tetrapods. Autostylic suspension has three subtypes as well. First one is Holostylic. It has upper jaw fused with the skull and lower jaw directly attached to it, and these are found in lungfishes, holocephali, for example ratfish. Next is Minamostylic. Hyomandibular becomes columella and the articular articulates with the quadrate, and these are found in many tetrapods. Third one is Streptostylic. The quadrate bone is movable at both ends, allowing high jaw flexibility, and these are found in snakes, lizards, and some birds. Last one is Craniostylic Jaw Suspension. It is a modification of Autostylic suspension. The upper jaw is firmly attached to the cranium. The hyomandibular becomes the stapes, which is a part of a middle ear. Quadrate becomes the incus and articulates becomes malleus. The dentary of the lower jaw articulates with the squamosal of the skull. Craniostylic suspension is the most derived form, representing a complete transition of jaw elements into the auditory ossicles of the mammalian middle ear, and these are found in mammals. Jaw suspension is not just about how the jaws hang. It tells the story of vertebrate evolution, feeding adaptation, and even how hearing evolved. From simple ligament-based suspension in primitive fishes to highly specialized mammalian skull, this concept bridges anatomy, evolution, and function. That's all for this video. Thank you.